there's more than one way to measure angles. Obviously, we know about degrees, but now we're going to talk about radians. And here we have a sentence that's going to be a little bit wordy at first, but you'll get the hang of it. A radian is a unit of measurement of an angle. Okay, so far so good. It's the way we measure angles. It is equal to the angle at the center of a circle. Okay, so now we need to draw an angle at the center of a circle. And that angle, before I read the rest of it, I'm going to just go ahead and guide you through that. So here's a segment right there. And we're going to say that's the radius for obvious reasons. And then we're going to draw another segment, and that segment needs to be just a little bit less than 60, and you don't have to be all exact about it. I'm going to do that right there because I want mine to be as exact as possible, just a little less than 60. Try to draw it about the same place as me. That's also a radius, clearly. Try to make that one a little straighter. That did no good. Okay, let's keep reading. A radian, a single radian, 1 radian, is a unit of measurement of an angle. So this is going to be an angle that is 1 radian. And it is equal to the angle at the center of a circle whose arc length is equal to its radius. So what that means is if I took this radius right here, took that, had a string, and then I just kind of wrapped it around until it came up to here, used the whole radius, and this was also r from here to here, then this would be 1 radian, okay? So if that sounds a little wordy, I'm going to word it a little bit differently, and it's actually what we just did. So I'm going to switch colors here, and I'm going to write a rather lengthy sentence that's going to help us understand this a little bit better. So 1 radian is equal to the angle created by taking the, not 1, the radius. Doesn't matter which one you take, we'll just take the radius of a circle and stretching it, not stretching like it, but wrapping it. I'm going to put wrapping it along the edge of the circle. So this is really, excuse me, this is really an arc length issue. As we go from here to here, this arc length is equal to the radius. And because the arc length is equal to the radius, we now have 1 radian. So now we get into this thing of, okay, well, how many radians are in a full circle? I'm actually going to write that down as a question. I'm going to write it in red. How many radians are in 1 full circle? Okay. Don't know. Let's find out. Well, here's the thing. With degrees, we know how many degrees are in one full circle? 360. So whatever I'm going to get for this answer is the equivalent of 360 degrees. So if I had 1 radian here and another radian here and another and another and another. Now, I already knew to make this a little bit less than 60. That's why we eyeballed it the way we did. And this looks about the same as that if we wrapped it around, maybe off a little bit. So I knew where this was going, which is why we drew it the way we did. But let's find out how many radians are in 1 full circle. And I think we can figure out how much is 1 full circle by coming over here and saying, well, the circumference of a circle is the diameter times pi. No one likes diameter. You might, but whatever. 2 times pi times the radius. Okay? Well, now really the question is, if it takes me 1 radian to get this far, how many radii would I have all the way around the circle? Well, the full way around the circle, circumference, is 2 times pi times the radius. So it's going to take me, check it out, 2 pi to get me all the way around the circle. So if I were to mark off, and I'm not going to be able to do this very well, but if I were to mark off every time I come across a radius, about right there, there's another radius. And about right there, there's another radius. I'm estimating. And about right there, there's another radius. And then there's another radius. And then there's another radius-ish. we have 1, 2, 3, 4, 5, 6, and a little bit more radiuses left over. And there's, let's see, 2 times pi is a little more than 6. Okay, so this right here is about, not exactly, but about 0.28, approximately 0.28 radii, and that is going to bring us all the way back around to one circle. So the answer to this question written in red, how many radians are in one full circle? 2 pi radians. Okay, so if I had, and this, we were expecting a whole number, right? We were expecting like, oh, there's 12 or there's 6, or well, there's not exactly 6, there's a little more than 6, because 2 times pi is, well, 6.28 and some change, right? So it takes 1, 2, 3, 4, 5, 6, and a little bit more to get us back around. We eyeballed it, but we also had this formula to guide us. So there is a conversion between radians and degrees, and the conversion is going to look like this, and I taught it multiple ways, and I found this to be the best way. So let's grab purple. I'm going to put radians divided by degrees. And we just said that it takes 2 pi radians to make one full circle, right? So if it takes, excuse me, 2 pi radians to make one full circle, which is 360 degrees, then, let's see. If 2 pi radians is 360 degrees, then why don't we divide both sides by 2, and we'll have 1 pi radians, it's still plural, equal to, well, divide that by 2, it's 180 degrees. So here's the thing. We can make it all the way around to the exact opposite end of the circle at 180 degrees by just doing not 2 pi, which will go all the way around, but just 1 pi. So radians over degrees equals pi over 180 degrees. Okay, we're going to use that as we move forward.